Right, hello, and again, we are, yes, I did say hello for about 1500th video. You're getting absolutely sick of my voice, but if you want to do some physics, this is where it's at, I'm afraid. No other DVD does it quite as good as me. I'm disappointed. I've done this purely because I'm not happy with YouTube videos at the moment, and I'm not an idiot, but you know, alright. Okay, so what we're going to be doing today, as I said before, is density. Now, density is, you can think of it as condensed mass. It's like the mass per unit volume sort of thing. Well, that's exactly how it's defined in the book. I am just a genius at this. Okay, so density. Well, it's only going to be a few minutes, this video. So, density is denoted by rho, which is sort of like a P, equals mass over volume, and can really inject in a number of ways to get mass is density times volume, for example. Now, you need to work out the volume of what you measure in. Now, you're generally given the formulas for this in the exam. So, what I'm going to focus on is densities and volumes of alloys. I'm assuming you're able to work out, with that formula, working out the volume of a shape. I'm assuming you can do that at AS level. So what we're going to go on to is we're going to go straight onto the big meaty bit, which isn't actually that meaty at all, because it's from McDonald's. So, it's going to be about alloys. Now, the two alloys we're going to look at are assumed to have two different densities. So what you need to do is you need to work out the density and the density of one, density of another, and the mass of one and the mass of another. If you're not given them two, you're only given one of them to work out the other. So let's do one on one of the questions here. It says a brass object consists of 3 times 10 to the 5 meters, 10 to the minus 5, so 3.3 times 10 to the minus 5 meters cubed is copper. So this is just a brass object. And 1.7 times 10 to the minus 5 meters cubed zinc. So they're two different metals, and together they make an alloy. Now the density of copper is really high, 8,900 kilograms per meter cubed. So 8,000. So P equals 8,900 kg per meters cubed. And the density of zinc is 7,100 kilograms per meters cubed. So you may be asking, well, I know it sounds simple. Well, if you are asking, then I'm sorry, but kilograms per meters cubed. So meters cubed is a meter long, so you've got a 2D shape and it goes into it by a meter. So you've got 2 by 2, meter by meter, and then it extends that way. So if this is the face here, it extends into it by a meter. And 1 meter of copper, 1 square meter, 1 3D meter cubed, if you can visualise it like that, is 8,900 kilograms. And the same principle applies, except for zinc this time, it's 7,100 kilograms. Now what it's asking us to do, it's asking us to find the density of the alloy. Now, we don't know, the first thing we don't know, well, actually let's work with what we do know from the formula. So we know the density of both, we know the mass, we don't know the mass of both, but we know the volume of both, meters cubed. So, how do we work out the the total density. I mean, we can't just simply add these two together and go, there you go, that's physics done, let's go and watch some GTA, someone play GTA on the computer screen. Which of course you don't because you're 16. But let's assume that if you're watching this video and you're 16, sorry about that. But, you know, just for people who might go, hey, you shouldn't be playing a GTA. Suddenly become Italian. You see all these wonderful things happen in physics, and your teacher probably doesn't give you the opportunity to watch an idiot make fun of himself so you can learn some physics. So the density, as we said, we can't add these two together. So the only way, what else we're left with is our total mass over total volume. Because the density is a new substance, effectively. So we need to work out the total mass over the total volume. Now I already said we can convert this formula to get mass. So P times V, or density times volume, equals a mass. Now we need to work out the individual masses so we can add them together. And so the mass of copper is the density, 8,900. So if you can't see this, pen's starting to go funny. 8,900 times 3.3 times 10 to the 5 minus 5 meters cubed. And that gets you an sorry, just let me do it on my calculator. And that gets you a value of 0.294 kilograms. And we're going to do the same for copper. So density times volume equals mass. And that means 7,100 times 1.7 times 10 to the minus 5 equals, and you can see it's going to be less, so that is in fact 0.121 kilograms. Now the total mass is, you add them two together, and then the total mass, sorry, I'm just seeing if you can see that pen's going a little bit. Yeah, you'll be alright. So the total mass is 0.294 kilograms plus 0.121 kilograms, which gets you a total mass of 0.415 kilograms. And that is your total mass. Now we need to work out the total volume. So I'm just going to rub this off so you can make a bit more room if you want to pause the video. Right? Just so that I'm going to leave our total mass there in the corner and use a different pen because this is starting to go. So that is our total mass there. We need to work out our total volume. Now our total volume is should rub the two masses out actually. So the mass of copper was 0.294 kilograms and 0.121 kilograms was the mass for the other one. So yeah, so the total masses, and as we rearrange the formula again to work out the volume, yeah. So I've got the volume next. So could you swap P and the V around? So the mass over the density is that, yeah. So it's 0.294 in kilograms over 8,900. I'm not putting the units in, but you should. 0.121 kilograms over 7,100 kilograms per meters cubed, and that comes to, let me put it in my calculator, 5 times 10 to the minus 5 kilograms per meters cubed. So our total, we've got our total mass here over our total volume, which is here. So P equals 0.415 kilograms over 5 times 10 to the minus 5 kilograms per meters cubed. As I said, I'm not writing the units on, but you should, just to save a bit of time. So P is mass over the volume, and if we divide them to, get my calculator, yep, and then that gives us a total density of 8,300 kilograms per meters cubed, and that is rounded, so it's not specific, just rounded, and that coincidentally is what the book gives us an answer. Yes, so that is correct. That is how you would do a density. Now obviously that's giving you the volume in the question, but sometimes when we ask to do that, but that is essentially the hardest bit of density. We hope you enjoyed this video, and we hope to see you in the next one. Again, if you have any comments, please don't be afraid to ask me. See you.